2.2 problem 9 discussion. Let's read the problem. Find n so that the nth term of the following two APs are same: 1, 7, 13, 19 and 100, 95, 90. So that what it means is that you have two APs here, 1, 7, 13, 19, other one is 100, 95, 90. At one particular point, the nth term of both series are equal. It can be 20th term, it can be 50th term, it can be 100th term also. Okay, so that is what they want to find. Which term of both series are equal? Okay, it looks little confusing. Don't worry, let's work it out. Let's mark what is given in the problem. It's an AP. Okay, first thing, there are two series. For the first series, A is 1, that is T1, and T1 is T1 equal to A, that's equal to 1, and T2 is 7. The same, A equal to 100 for the second series, T2 is 95. So let's write it out. So for the first series, A equal to 1 and the second term is 7. For the second series, the first term is 100 and the second term is 95. So what are we asked to calculate? We are asked to find the nth term of both the series for which the values will be same. So we need to calculate n. Okay. Actually, to be very specific, I think probably I should write Tn of the first series must be equal to Tn of the second series. Okay, but anyway, I'll make the correction for the next version. Okay, great. So let's write the formula. Tn equal to A plus n minus 1 into D is our normal formula. But as you can see, for the first series, we have A and we don't have D. And n is also not known because that's what we want to calculate. So which means this formula, as of now, we can't use it. So let's find out D. D is T2 minus T1. Sorry, it's 1 is missing here. So it's T1. Okay, so that can be found for both the series. Then you substitute that here and get an expression for Tn. So the way to do this problem is that first find D for the series 1. Then using that series, let's say the nth term, that is Tn of the first series and Tn of the second series are equal. So we'll have to find the nth term. So once we know D, you substitute A, D and n is to be calculated and write an expression for the nth term for the first series. Repeat the same for the second series also. Then you equate those two equations. You will be getting an equation in terms of n. Solve that equation for n and you'll be able to get the answer. Okay, so anyway, it looks a little cloudy, right? Now let's write step by step. Step 1. Let D be the common difference. Calculate the common difference D using T2 minus T1 for both the first and the second series. So in the first series it is 7 minus 1 and for the second series is 95 minus 100. Right. Now let's take the first series, substitute the value of A, which is 1, and D, which is just now calculated, and that is 6. Okay, in this formula, and get an expression for Tn. So what will you get? You will get Tn equal to 6. Oh, sorry, 1. Oh, A is 1, right? 1 plus n minus 1 into D. D is 6 here. So this is what you'll get. This on simplification, you will get Tn equal to, this is 1 and this is 6n minus 6. So minus 6 plus 1, that will be minus 5. So Tn will be 6n minus 5. This is an expression. The nth term of the first series is given by 6n minus 5. Okay, it's the same as this formula, but only thing is that what you have done, we have substituted the value of A and D and simplified it. So the nth term of the first series is given by 6n minus 5. Okay, do the same. So if n equal to 10, you'll get the 10th term. If you put n equal to 20, so 26 are 120, 120 minus 5, that will be 115. So the 20th term you'll be able to calculate. Okay, so that's what this expression is all about. Repeat the same for the second series. So all we need to do is that substitute A equal to 100 and D equal to minus 5 in this case. Okay, I'm using the actual values to bring in to make the make it little simple for you to understand. Okay, so in Tn equal to A plus n minus 1 into D, which means that Tn will be equal to A is 100, so 100 plus n minus 1 and D is minus 5, which on simplification will get you Tn equal to 105 minus 5n. 105 you are getting it, 100 this is minus 5n, and this 5 minus the minus will become plus, so it will become 100 plus 5, that is 105, and minus 5n. Okay, so that's the second equation. But we know the nth term of the second series and the first series both are equal, so which means the Tn given here is equal to the Tn given here. Alright, which means the right hand side of both the equations are same. So equate the RHS and solve it for n. What does it mean? So 6n minus 5 will be equal to 105 minus 5n. You will get an equation in n and solve it for n. That's all it is. Okay, so it looked very difficult, but now I think it is made easy. So pause the video here and try to work the problem on your own. Okay, and after working, come back and check the solution. Okay, here we have the solution. So for the first series, a is equal to 1, and for the second series, a equal to 100. So this is 1 and this is 100. This is the first series and this is the second series. So let d be the common difference. So common difference is given by the formula t2 minus t1, and the nth term is given by the formula tn equal to a plus n minus 1 into d. So for the first series, d is 7 minus 1, that's equal to 6, and the second and the nth term is tn equal to a plus n minus 1 into d, putting a equal to 1 and d equal to 6. On simplification, you get tn equal to 6n minus 5. The same you do for the second series. That common difference for the second series is 95 minus 100. That is the second term minus the first term. Second term is 95, first term is 100, and so that's minus 5. Please be careful, it's always second term minus first term or third term minus second term. It goes on like that. Okay, so that is minus 5. Okay, and substitute all these values here. Tn equal to a, which is 100 here, plus n minus 1 into d. D we calculated as minus 5. Okay, so Tn will be 105. This 105 minus into minus becomes plus, and that will become 100 plus 5, and then this is minus 5n. Okay, so Tn equal to 105 minus 5n. But we know the nth term of the first series and the second series are equal, so which means 6n minus 5 will be equal to 105 minus 5n. So given that the nth term for nth term Tn for both series are equal, so thus equating RHS of the equation 1 and equation 2, we get 6n minus 5 equal to 105 minus 5n. So that for minus 5n, when it goes to the side, it will become plus 5. So 6n plus 5, that is 11n. 105, this minus 5n comes to this side, it will become plus 5. It will be 105 plus 5, so it will be 110. So 11n will be equal to 110, n will be equal to 110 divided by 11, that will be equal to 10. Thus, there are 10 terms in both the series. You got it? So all you need to do in this problem is that you have to take, use the nth term expression Tn equal to a plus n minus 1 into d, and get the expression for Tn for both the series, equate them and solve n. Okay, I hope your working is right. If your working is not matching with our solution, see where it is not matching and make suitable correction. Okay, and if your concept is not clear or you have not understood the problem clearly, please go back to the discussion part of the video and review it. Okay, thanks for watching the video.